Okay, we are in live.
Okay, brilliant. I take it that the chat window here is where I'll see people's chat. Okay. 21 attendees. Hello, everybody. Just 2 seconds. I'm just adjusting my microphone. There we go. Can everyone hear me okay? Everyone doing all right? Cool. Just give it 1 more minute. Oh. Okay, fair enough. Right, I'll get started. Hello, everyone. I don't know whether there's a chat or anything where I can actually hear any feedback from folks, but sure, Mario will let me know if there's anything I can do. All else fails, if anyone's got any questions, throw them out on Twitter or something. I'll just get started. Cool. Hello, my name's Simon Painter. I'm just going to be talking today about getting lazy with development, which is one of my favourite topics because I flipping love being lazy. That's kind of one of the drives of my daily work. And this is a talk about some of the techniques I use for achieving just that, how to get the maximum amount of work done with the minimum amount of effort possible. A little bit about me. I've worked for quite a few places. I've been slowly adding to this as the years have gone on, but I'm not going to bother waffling through all of it. I've worked for a whole load of different companies. I've been in this business for about 16 years or so now, and I've worked in government, I've worked in retail, manufacturing, all sorts of stuff. I was briefly one of those slightly scary contractors that your mum used to warn you about. These days I work for Multistep. I don't know whether they have those in Italy or wherever you happen to be, but certainly in the UK they're well known for their particularly excellent brand of yogurts. And I have been promised since I started working there that I would be getting some free yogurt, but I haven't had it yet due to the pandemic. Darn it, I've been looking forward to my yogurt. Also, if anyone is ever interested in reaching out to me to ask any further questions, to get in touch, or to talk about my love of Doctor Who, then my contact details are at the top. Oh, I just thought my camera's not on. Let's just switch that on. There we go. I don't know whether you can see me or not, but here I am. Hello. Right, let's move on. So I present now the great debate of our time. This of course is a screen capture from Back to the Future, but these two men represent a great dichotomy in work. One is the serious man, the one that does everything serious to the book and properly, and the other is the slacker, the one who takes it easy, the one who does as little work as he can. I would argue that the guy on the right there, over the course of the film, has an awful lot more fun. He's the one that gets to ride in the flying time machine after all, and he's the one that I want to emulate. So where on earth can I find us places where we can save as much time as possible? Well, these are, broadly speaking, are the sections of 2 seconds. Are the sections of a project as they go on, broadly speaking. Okay, gather requirements, design a solution, coding, testing, enhancements, sure. So of these, where do we spend the majority of our time? Well, gathering requirements is typically the work of a business analyst. Designing a solution may or may not be you, might also be a systems architect. Lost the chat. There we go. Coding, well, that's us, that's devs, that's us. Testing, maybe, maybe not. And enhancements, that's back to the devs once again. So coding and enhancements is where we can actually make a difference as developers. And of these two, I'd argue that enhancements is the one where we spend the majority of our time, because at this point, if I was in an actual physical meeting room, I'd probably get a show of hands, but I could certainly, for one, vouch that I've worked on code bases upwards of 20 years old, and I'm pretty sure that that's nothing particularly unusual. So that's probably the place where we can make the majority of our savings. There is a lot of work right at the beginning when we do our initial coding but that's peanuts compared to how long the thing exists, and probably over the life of the application, in a lot of cases, it's probably not anywhere near as much of the amount of time as is spent on it as doing enhancement work, adding new features, putting in fixes, that sort of thing. So what can we do to try and make that process an awful lot easier? Well, these, as I understand it, are the majority of the reasons that we have issues when we're developing. Unclear requirements, project management issues, and legacy code base. Now, of these two of these three, two of them are nothing we can really do very much about. Unclear requirements, well, that's down to business analyst, probably. Project management issues, that's between yourself and whichever manager you happen to believe in. And legacy code base, now that's something we can do something with. Legacy code base is one of those problems that we all have. And this is the biggest problem we get with the legacy code base. What is this code actually meant to do? I have this problem all the flipping time. Where I am now is not too bad, but I've worked in places where there've been functions with upwards of 2,000 lines of code where it is utterly unclear what this thing even does. And that is honestly a huge problem. And the next section or so is going to be about finding ways to deal with this problem. How can we actually make our code readable? By readable, I mean more maintainable, and thus save ourselves an awful lot of time. According to me, these are the basic components of a function. So we've got parameters, that's stuff coming in. We've got return value, that's stuff going out. But in the middle, we've got these two items here, code structure and business logic. A code structure is how do we achieve what we're trying to do, and business logic is more like what is it we are trying to do. And I'd argue that an awful lot of the problems that we get with readability in code is where these two are blended together. There's a concept in audio engineering called the signal to noise ratio. So a signal to noise is the ratio between the signal, which is the thing you are actually trying to listen to, and the noise, which is everything that you're not. The signal is the piece of music or the voice. The background noise is hiss on a cassette, or rumble on a record, or if it's a Justin Bieber album, the album. You get the idea. It's the stuff you don't want to listen to. And that's the sort of concept I want to apply to computing. I want to reduce the noise. The noise is code that we have to write in order to achieve our goals, and the signal is what we're actually trying to do. That is what you would say if that's what you'd say to your manager if you asked them to describe what this thing actually does. So starting incredibly small, I'm talking about noise right down on the individual line level. Here's a function. Now, I'm not in person and I can't see any chat from anybody, so I'd normally give folks 5 seconds to try and analyze this, and yeah, it's an awful lot of code to do something that's really quite simple. And what this is trying to do is go into the configuration settings, pull out a particular setting, check whether it has a value, and if it doesn't, give it a default. It's relatively simple, but that's an awful lot of code to achieve this. And the way I'd simplify this is with the use of extension methods. I'm hoping no one has any issue with extension methods and understanding what they are, because otherwise it's going to be a tough talk for you. But here we go. So this is a couple of extension methods, and I'm saying attach to string and give it a default value, which is either another string or an integer. Do a check against white or null or white space, and also when it's the int, do a try parse. And if all of that works, then great, return that value, otherwise put the default out. Easy peasy. That means I can reduce all of that code noise into this. Technically kind of one line of code-ish, sort of, but it's very easy to read now. One setting, one line. And I've got descriptive functions names which say what it is I'm trying to achieve. It's not just a whole load of code noise where someone has to look at it for a while to try and understand what it's trying to do. It's simple, it literally says it. Go to the app settings, grab this guy, and then apply a default value of 5 if it doesn't exist. Easy peasy. So talking about extension methods, they tend to get a little bit of a bad rep. So I'm going to talk through my commandments of extension methods and how to make them useful, how to make them work for the code base, and not ruin things. And when I say commandments, I mean, you know, use some common sense. It depends, as always, what are you actually trying to achieve? So rule 1, no business logic. Business logic is the thing you are actually trying to achieve. That's the most important part of your entire code base. You want that right up front where absolutely everybody can see it. You don't need to hide that. The stuff that goes inside extension methods is kind of like the hypothetical 1980s Thundercats snarf action figure. You own it, you don't want to get rid of it, but you don't really also want anyone to actually see it. So we'll maybe stick it in a box, close the lid, and just tuck it away somewhere at the back of the code base, safe in the knowledge that it exists, but you don't actually need to see it. That's extension methods. Keep them compact. The moment you're starting to put more than a line or so of code, I aim generally for my extension methods, if wherever possible, to be 1 line long. But sometimes I have to go longer because I've got no choice. But the moment you've gone over that is the moment you need to consider, is this actually business logic, or do I need to maybe create a couple of methods? Who knows? Depends on the circumstance, but start questioning yourself if you're making more than a couple of lines in them. Keep them generic with a, well, literal generic, because then you can reuse that same function across an awful lot of different types, and that makes them more universally applicable. Portable, keep them portable. By portable, what I mean is you should be able to take this extension method, pick it up from one project, and drop it into any other C# code base in the entire world, provided you know versions of .NET, etc. But that's the point. The point is that it's something that's incredibly universal. The moment you start putting anything that's not universal, it starts to suggest that business logic has crept in, and that once again should be right up the front, not tucked away in an extension method. And use them whenever there's boring, repetitive code. That's the point for me. I am trying to reduce the size and complexity of my code base, take away the code noise, and then just push, hopefully, the business logic to the front where everyone can see it more easily. And also make them useful. I was doing this talk some years ago, and someone told me that they worked for a company that created an extension method called isTrue, which literally returned the Boolean true. I'm not sure why that existed, but that's not useful. So I'd avoid stuff like that. Make them actually useful. So a couple of examples of extension methods. These are sort of things I might consider creating, depending on my circumstances. This is a parser. A parser takes a string, which is the contents of a CSV file, splits it based on whatever you want to split the line by, which typically is a new line, and then split again by whatever you feel to split by, which is typically a comma. And then bang, we've got one parser which you can attach to any string, and that will make it fairly clear generally what you're always trying to do. Here's some you can attach to enumerables. So just taking away the tedious business of checking not only is the enumerable empty, but potentially is it also null, and avoiding null exception errors, one of the great banes of our existence, and handling this a little gracefully and with a function name that actually makes it clear what it is that you're trying to achieve. This one's for dictionaries. Now, dictionaries are actually one of my very favorite features in the whole of C#. I love dictionaries, and they are brilliant, they are useful, and they're such a flipping space saver in terms of what you can do with them in your code, but they have a few awful tendencies. And the one is that for some reason you have to specify the key and the value separately in different lambda expressions when you create the dictionary, when quite often with some data types it's really quite obvious. If it's a key value pair, well, why am I even bothering to do this? So there we go. I could just create an extension method, and I could create another one for two field tuples as well if I wanted to, because it's probably fairly obvious. So it's just taking away a teeny tiny little bit of line code noise. It's not much, but you know, every little helps. Or if you do an awful lot of turning dictionary enumerables into reports, where you could throw in a quick little extension method to turn an enumerable into something that groups by and then gives you back a dictionary with the key and a count attached to it. So you can easily throw a report together with this one. These are just things I've used in the past. There's all sorts of things you can do yourself, and it's all down to yourself and your imagination and what you're actually trying to achieve. So that was stuff for individual lines. Now moving on to sort of larger structural pieces of code. Now I'm British, as you can tell by the funny accent, and there is a cliche that British people like to talk about the weather an awful lot. This is entirely true. We actually do. We talk about it tons, mostly because you can have up to 4 different types of weather in a single day here. And something I used to do when I worked for an American company was ask them about the temperature outside. And of course, Americans working in Fahrenheit, they would say things like it's 100 degrees outside. Or for me, working in centigrade, that sounds like you should surely all be dead, because 100 degrees is hot enough to boil water. But no, I think it's about 34. I don't know. I don't really mind. But the process for converting centigrade to Fahrenheit is this: multiply by 9, divide by 5, add 32. Wait, but yes, because of course it is. And then I'll do a conversion which turns it into a string with a nice little bit of text around it to make it clear what we're actually doing. Great. Well, that's wonderful. This is a trivial example. I mean, honestly, if I saw this in a code base, I'd probably be fine with it. But there are other operations that are multi-step like this, where you take a value, do something, take another value, do something, and so on and so forth. That can be more costly, especially if actually the function continues on for another 1,000 lines or so. If this really were like that, then var a, the a there at the top, is still in scope for the entire rest of the function. And on top of that, that a equals, and the other thing where you're passing a in, that's just noise again. We don't actually need that a. It just exists because you have to have it there. I mean, yeah, I could actually convert this into a one-liner, but let's imagine that this is something more complicated. I don't want to get bogged down in the specifics of some particular bit of business logic. But you get the idea. This is one of the greatest tools you never really realized you needed. It's a tiny, tiny, tiny little extension method. So it takes 2 generics, the input type and the output type. We are attaching to the input, and it's a generic, so therefore it attaches to absolutely everything in the whole of C#. And then we'll take a func, which converts input type to output type. And all we do is call the func and pass this in. Done. Means I could convert that whole thing into something that looks like this. It's kind of a bit like link select statements, except we're operating on a single object, on any old object. If you passed an enumerable into this, then it would see X would actually be a whole enumerable and not just the individual items. And this is called a monad, by the way. It's a functional C# thing. And I'm not going to talk any further about this, but this could potentially be something that will save you a whole load of time and effort. And there's no variables which exist for any more than they need to strictly. That there's no a which is called into existence and held there. Each of these x's exists for the very moment that the function is executed and then ceases to exist. That's it. So it's nice and compact. It does mean we've got the word map all over here, but that's fine. Basically, you know to ignore it and just look at whatever is inside the whatever the lambda expression is inside this. So this functionally is the same exact thing as in the previous version. Oh, excuse me, I'm so sorry. Something went down the wrong hole there. Right, T. So this is if you wanted to do a little bit of logging inside that chain of functions, because that's one problem we've got. Now that we're a big chain of functions, how do you log? I'm so sorry. Same exact idea, except this time we're taking an action as our parameter. An action is like a func, except it has no return type. So it's basically a read-only version of the map. And it looks kind of like this. So inside T there's a T in the middle. I've heard this, T is not a name I invented. This technique has got all sorts of names. I've also heard it called a tap. There may be other names for it, I don't know. I think in the JavaScript world you tend to see it's tap. But there, inside here, we can run a log. So this here would be equal to temp multiplied by 9 and then actually divided by 9, so it's the same again. But so this log would be logging a 9. Not sure quite why that. Weird. But anyway, it's a read-only view at X, which we could pop into a log. If this were the real world, you'd probably put something a lot more descriptive than simply the variable. You'd probably put a load of text there too, but fine, you get the idea. The principle, I think, is sound. Here's another example of something that's one of those eternal problems. So I've created a little local function. I'll call it prepend hello. Prepend meaning adding it on before. And I'm going to take a string, and this string is somebody's name. And I'm going to say, hello, whatever your name is. Call it twice. Now, clearly, I'm calling up the HR records of the devil or something. Awesome. But that's fine. My point is, though, that as you can see in the comments, this one I'm saying works. We get back a name, and this one doesn't. This one returns a null. So if I call my prepend function twice, as it is right now, and grab the name out of that, if person 2 is null, now what you're actually going to get is a crash, because person 2 null, trying to call the name out of it, is going to call a null reference exception. So is there ways of dealing with this? Well, there certainly are. First off, you could insert an awful lot of boilerplate code and do null checks, but that is moving against the principle that I'm trying to work to, which is to minimize noise. Or we could add in an extension method again. Do if not null. Now this line here looks a teeny bit terrifying, but actually this is just the generic version of a null check. So equality compare for whatever the type is, get its equality compare and then check it against the default value. This is your usual default, so null for most things, 0 for an integer, false for a boolean. Check it against. If it is not null or whatever, because primitives can't be null usually, then there we go, actually run the function. Otherwise, just return the default, which would probably be null again. And there we go. We do person1 dot do if not null, pass in a function here, and this function, this do if not null, will do the null check for you, and then if it's not null, we'll actually execute this. If it is null, this will not be executed. So the null reference exception doesn't happen. Easy, problem solved, and we haven't had to fill the code base up with a whole load of rubbishy noise. Now, I did say dictionaries is one of my favorites, so this is an example using dictionaries. And this is a lookup for what is, according to the dictionary, the best TV series in the entire world. I'm not going to take any arguments on that. This is Doctor Who, the British science fiction series running since 1963. So the lead actor, the Doctor, has been played by many actors over the years. And I've created an imaginary scenario where I have a dictionary where you give the number of the Doctor and you get back the actor who played them. And in my imaginary scenario, I'm creating a function to get. Now I could call it twice here. Once getting the passing in 1, which will give me the name of the first Doctor, the boss, William Hartnell. And if I pass in this 100, something else will happen. Now, it won't be a null reference exception, but it's effectively the same sort of thing. This is the crazy thing about dictionaries. For some reason, if you try to get a key that doesn't exist, it explodes on you. It throws an unhandled exception. I don't know why this should be, but this is how it works. So I add, this is my fix for the problem. And I often put this in almost every code base I work in. This is something which converts a dictionary into a lookup function with a default value. And effectively, it's kind of like a gate where it sits between the user and the dictionary. And every time you attempt to go to the dictionary, it does a check to see whether what you're going to do is going to cause an exception. And if it's not, then you actually get a value. If it is, then we'll intercede and return something else. Either with this version, we'll just return whatever default is, null or whatever. And with this, we provide a default value of the correct type. And this, for to my way of thinking, actually turns dictionaries into something genuinely useful. Now it looks like this. Now I'm going to give a default of don't know as a string. That means if you call get Doctor 100, you'll actually hit the extension method. The extension method will see that the key doesn't exist, and it will return don't know. So you no longer need to worry about null references in the dictionary. And it does mean, though, that we have to change the type. It's no longer a dictionary, it's now func. But the func sits in between this function call and the dictionary, and this is what makes the call on whether to actually go to the dictionary or not. So now let's imagine that we wanted to get an array and call get doctor 3 times to get, I don't know, every other doctor. I don't know why you'd want to do that, but bear with me, bear with me. So you could literally call it 3 times and stick it inside an array, but that for me is still too much noise. I don't like that. So you could do this. This is one option, reduces the noise somewhat. This is an indexer. Attach it to the doctor data class, and we'll take an int so that it's just a straightforward, whatever this is, dd doctor data, dd, call it 1, 2, 3 with an index. That's a little bit neater. That's not bad. I like that. We can go a step further though. Did you know that an indexer can take a params, which it can? And this means that you can take your 3 different calls passing in the index that you want each time to just literally this. You can go dd and then just do the thing I want 1, the comma, the thing I want 2, comma, the thing. That is it. So all of that logic is contained in this one little function now. That's pretty handy. And if we're creative, there's all sorts of little ways that you can play around a little to reduce the amount of boilerplate code writing like this. Now, I've got some videos in this. I'm hoping they're going to work. They don't always. Oh, fingers crossed, everyone. But this is one of my pet hates. And I'm going to continue to moan about this until finally I see the day when people stop doing it. So this is an imaginary scenario. And this imaginary scenario involves me trying to create a report about taking in an object and aggregating, taking an average, and then passing that data on to some other source. And we've also got a message to say that no data was received. Now we've got a catch to say that, you know, it's pretty standard. Nothing. This is entirely imaginary, but you could see this happening all over the place. And that's fine. So we've got to unit test this because we're good folks. In fact, if we were even better folks than this, I'd probably write the unit test first, but bear with me. So a positive test to say, here is some data. Did everything work? Good. We've covered all these lines of code. And another test to see what happens when no data is received. There we go. We've got an extra line there. Lovely. Some more checking being done. Some more checks to those lines there. And a test to see what happens when there's an unhandled exception. And we can see that our code is pretty solid. That's great. There's no problems. There really isn't any basic problem here. Not really. But then the business turn around and say that they want to get property 2. We want the same exact report, but for a different property. Now, I know that what an awful lot of people do is this. Just copy and paste the whole thing and change 2 properties. That, I mean, yeah, that you can absolutely do that. That is a way, and I have seen this, but this doesn't really stack up. This is not a method that scales up very well. What about once we've gone from property 2 to property 3 and 4? What happens when we've gone all the way down to property 900 or whatever? That's a bit of an exaggeration, but that's an awful lot of replication of code. And what if it turns out that there was a bug in the prop 1, something that no one caught, and every single version of every single one of these new functions since then has been replicating that bug? Now, this is a scenario that I've actually seen happen. There was a place I worked where there was a rule base that had to be created every year based on the old one, but with a few changes. And that's fine. So what they did every single year was they copied the whole entire previous rule base, made the new adjustments, and they also had to maintain all previous rule bases. So you had all these things side by side, and it did indeed turn out that about 6 years ago, someone had introduced a bug, and every single version of that code base from that point on all had to be updated separately, and that was a heck of a lot of work. So although this duplication does, in the short term, give you a saving, long term, it doesn't. Not really. Not when it turns out that you have to maintain this thing. And that, as I've said, is where code spends the majority of its time, is maintenance. It's the quick, dirty, easy solution, but it's not the smart solution. The smart is, I don't know what the proper name for these is, but I'm calling them donut functions. How I do it is something like this. Take your first one, your prop one. Now, when there was only one, it's fine. There's no real issue, but turn it into a generic one and then request a func, which is saying which is the property I actually care about, and then use the func to generate out the property. So now I've got a private, which will work for potentially absolutely any property whatsoever. And then I can expose a public method, which, there we go. I can just call the generic version and then pass in the report. Pass in the property that I'm actually interested in this time. Done. And I could do the same with the second. So it means that every single time that I want to add in a new property, I just add in effectively one line of code. I could even go a step further, and I've got no issue with doing this personally, and actually expose the func as part of the public interface and just let the user make the selection on which property. That would be fine with me too. In fact, that would probably work better with the solid principles. Let's just show that again. Okay. And another place where I use this quite a bit. Now, I don't really care very much for EF, that is Entity Framework. I'm not a big fan of it, but when I have to use it, I do. And it has an awful lot of boilerplate associated with it too. If you don't want to have a code base that struggles to run, then you'd have to put a using statement around your query. You'd have to call a toArray there to make sure that you're not still connected to this after you've exited the using statement. And well, I'd never actually not do something with the error, but this is a bit of sample code. So this means that what we can do is ask for a func, which turns a queryable to a queryable, and then we'll just run this query in here. So this is a generic version of connect to this data store, and then we're going to expose what your query is out to the user. They can make a choice on the query, write whatever they want, and we'll handle the using statement, we'll handle the throw to try catch, we'll handle the calling toArray at the end. Done. This does assume that we're on table one. There's probably ways you can play with generics to expand that out a bit further, but this is fine. I'd have no real issue using this. So a bit more playing with func. This is a valid set of validation rules for a username. So I'm going to say that it can't be null or white space. I'm going to say that the length cannot be less than 2, and I'm going to say that the length cannot be greater than 20 for arbitrary reasons, and it cannot be the word Justin Bieber because it's not allowed. And each one of these has a lot of repeated structure. We're going to check each thing, return false early if it doesn't work, and then return true at the end if it did. Or we could just switch it all into a nice little extension like this, a validate extension, which takes a params. Now params is ever such a time saver. A params containing an array of funcs, and each func turns whatever the type is into a bool. And then we could call, this is just standard link all, and all means go through each item, evaluate whatever function is in here, which is to pass the starting method, the starting value into the function. And if any of these returns false, all means that they must all return true. So returning false means we terminate the process at this point, don't bother evaluating the rest of the predicates, and return false. Otherwise, if we get all the way through this array with every single one returning true, then the whole thing returns true. So all of that logic, all of that repeated if blah, return false with a true, that is all now captured within this structure. And that's now what our function looks like. And that's a lot easier to read. There's no structure getting in the way. And if we ever wanted to throw in an extra rule, it's literally just an extra line with a lambda expression in right here. That's nice and neat and easy to read. And you can use this all over the place. This is an alternative way of doing the transformation I did earlier on your conversion Fahrenheit to centigrade, and it's using an aggregate. Excuse me. Aggregate is one of those great things in C# that nearly no one seems to know about, but I adore. And what it means is give it a starting value, evaluate through the array, which is an array of funcs, and there are two properties in this lambda that I give it. This is the accumulated total so far. This is the current item. So it's whatever this is, so it's the starting value. And then each time we go through this array, we go through each one of these funcs and pass whatever the current running total is into the func, and whatever comes using the x being the func, and then return that back as the new running total. Then the next time we go to the next func, this is equal to whatever the running total was, whatever's returned from the last lambda, and then so on. So it's the exact same thing as with the dot map, except now we're doing it in extension with an aggregate, which is another completely valid way of doing this. This is a really simple factory. Now, a factory is looking for the type of whatever t is, and then returning the new proper instance. I'm making stuff up. It's like a I do stuff thing that can walk or fly, and with a default of walk. Well, a neat thing that a lot of folks don't realize is you can actually put type obs inside dictionaries as the type that you're looking up by. So you can turn a dictionary into a really crude factory, where you just pass in the type you want, and then you get out whatever. Now, you'd probably actually want to put a more complicated constructor here, maybe a call to a function, but that's fine. The lookup structure here is perfectly nice. And I've called toLookup with default, which I showed earlier, so that we can also create a default and not cause an error if you pass in a type that we've never heard of. How are we doing for time? Cool. Right. Part 5. So enumerables are also a great way of being lazy. I love enumerables, but a lot of folks don't seem to understand just how powerful they are if you leave them as enumerables. Most folks seem to be content to call toArray or toList at the first sign, but actually if you don't, they can be kind of cool. Because an enumerable, yeah, I know, I can't draw. An enumerable is actually not data, it's a pointer to data. It's a pointer to where the data is. So it has two functions that it can call out of it, and one is get the current item and the other is move to the next one. So right now this guy here, this enumerable, it doesn't know that it's pointing to an array of strings, but it doesn't know what's in any given item until it's actually enumerated. And you can crack this open and create your own custom behavior. So and also you can put funcs in there. So imagine that you didn't want to actually update the enumerable because there were funcs inside which contained expensive operations, maybe they're database lookups or something like that. And it won't actually do them until you enumerate. That's the thing about enumerables, they're lazy by definition. They only actually loop and evaluate whatever's inside them at the point at which you call a for each or a toArray or something of that sort. So if you actually call toArray and modify an item, you've actually created two arrays. There's the original, which is actually untouched, and you've called toArray, passed in a modification to the third item in the second array, the separate array, but there are two arrays now in memory. Now hopefully it's been done in such a way that this isn't really in scope anymore and is disposed of, but it could end up with both arrays still in scope. And this is my way of dealing with this. This is adjust. So what I'm saying is attach to enumerables, have a func which says, given whatever the item is, whatever the position of the item is within the array, and return true or false depending on whether I should do a replace. So this is a should replace function. This is saying, given this item and this position within the array, decide whether to replace or not, and this is the replacement. And this is just a select with the overloaded version where we're actually containing the item array, the I, as it were, the I in a for loop. This is the position within the array, and then calling should replace and just making and letting it make the decision. It means I can do stuff like this. I've got an array. I'm just going to put ABCD in it. Call array adjust, and I is equal to the position in the array. So position is 2, which is 0, 1, 2. That's this one. Then replace it with Z. This is actually doing the same thing but in a different way, and that is checking against the item value, which is also C. So these are doing the same thing, but at the point that array C exists, we haven't called toArray on adjust, so it hasn't actually done it yet. And if you exit this function and for some reason you never call toArray on this, or you never use for or for each, then actually these operations will never be done. These are potential operations sitting in memory that haven't actually been done. And this is kind of what it looks like. It's a series of gates between the enumerator, the thing actually running the enumeration, and the array. And whenever an item is requested from the enumerable, it'll pass through each gate, each adjust call, and then make a decision on whether to just pass it through or whether to step in and make a replacement. So it means it can adjust the array without actually adjusting it. This is a similar method for comparing consecutive numbers. And this is where we're actually going to crack the enumerable open and have a look inside it. So the enumerator is the thing that actually runs the enumeration. This is the engine inside an enumerable which runs whatever's going on, the process of moving from item to item and getting the current. And if we get it, now I'm just calling this here, and I've made another. This is an any with a func which has two items, which is the current item and the previous one. In my case, you could do it the other way around, say current and the next, but whatever, I don't mind. I'm going to get the enumerator and then pass this into the other any. This is my extended version of any. This is an any which now takes the enumerator. There we go. And this is a recursive function which looks at this. This is the enumerator now and has the func. And I'm going to say call move next. Now, an enumerator starts at position -1 until you attempt to enumerate it. If there are no items, then it just returns null. It returns false. If there is an item, then move next returns true, and we can call map to say call any. That's this function again. If there are items. Otherwise, we just return false. And then we evaluate the any, that is this again, but to using f. Oh yes, there we go. So that's right. Sorry. Yeah. So this is deciding whether to move to the next or continue. And this one is finally saying, given that there's an actual item and we've moved next, call f and evaluate it. Pass in the prev, which we've kind of like popped here in. There we go. It's this.current. So this is calling move next for the first time, and then holding that, passing that as the next. So yeah, sorry, I haven't looked at this code for about 2 years. So what we've done is start with the enumerable, move to the first position, hold back that first position item, and then start a sequence where we're recursively calling through based on comparing the prev, which we're kind of holding in our pocket, against the current. If they are a match, actually that's the function that we passed in, as are they the same? It's actually the same. The previous one is 1 plus the current one. Sorry, the previous one plus 1 equals the current one. Call that here. If that's true, then return true. Otherwise, continue to call any again. This time the current is passed in as the previous, and so on and so forth. Otherwise, finally we return to the end. Move next returns false, and we return false. That took me flipping ages to explain, and that was very tedious. But the point is that we can create a function called contains consecutive numbers, pass in our array, and say call our new extended any. We've got an x and a y, and what we can do is compare the current item against the previous value using a custom enumeration. It's something worth playing with, and you can create all sorts of weird and wonderful effects. Now, okay, we've still got a few minutes, I think. Are we okay, Mario? Okay, I'll just blast through this really, really quickly because I'm aware that we need to be getting off. So another thing you can do is using attributes. So this is again returning to Doctor Who, and I'm imagining we're trying to parse the some CSV data of episode data for what was when I wrote this talk, the current series of Doctor Who. There's been at least one more series since then, so this is a little out of date. I probably need to change these slides, but fine. And here's a quick parser to. Oh, there's a question. Considering that for me the readability of code is priceless, how big is the performance using extension methods with func and action? That's a very good question. That's a very good question. That method with the adjusts and with the funcs and the actions and so on, when we were looking at that first sort of set of maps and things, no, that's fine. There's not really too much trouble there. We're using the adjusts, that's holding an awful lot of stuff in memory, so there could be potential memory issues there, maybe. Depends how long you wait before you actually call to array or whatever and execute the operations. But the more you hold in memory, you could potentially have issues. But it depends on what the driver is. The actual performance issue in most cases is going to be negligible, if any. You might even get some small benefits on the fact that you're not necessarily carrying out each of these operations under certain circumstances. But it depends if the overriding concern of your business is efficiency and speed. This may not necessarily be what you want, but for the vast majority of people, readability and maintainability are far more valuable than efficiency, which is very easy to just throw a bit more RAM and a bit more CPU at something. It's very hard to deal with a horrible code base that's hard to work with. So long term, I would argue that given that our time tends to be incredibly expensive to the business, I'd argue that the more time we can save on development is probably long term going to save a lot more money for the business than writing code that may not be the absolute most optimal. If that is the absolute only concern of your business, what honestly are you doing working in C# anyway? Because there are probably stuff that you could be doing in C or C++ that would probably give you masses more performance. C# tends to be for sort of medium-sized businesses where that level of performance isn't necessarily a factor. I hope that answers the question. So, as always, it depends what you're trying to do. There might be a small hit, maybe. Some cases not, but I would argue in majority of cases, if you're smart, it doesn't really matter. Okay, I can't actually see the chat question, so I don't know what anybody's saying. Right. So yes, anyway, we're parsing this data, split on new line, select out to array, and then just select the fields that you want. So the title comes from item 1, which is this one. The season is hard-coded to be 11 because that is the season. There are now 12 seasons of Doctor Who, so this is out of date. The number of episodes, because in the old days, Doctor Who was a serial, so each story was split over many episodes. That's what that's all about. But in the modern series of Doctor Who, there's only one, so we'll hard-code that to 1. And then the writer, which is field 3, 0, 1, 2, 3. There we go. Done. Easy. But then we look at a CSV for the previous season, for season what would that be? 11. There's an extra field in here. This one. This is not which episode is it within the season. This is now which episode number is it within the whole of Doctor Who. There's been quite a few stories over the years, as you can see. It's been running since the 60s. It's not a big deal, except that that's thrown off all of our index values for selecting out of have I been thrown out? I've got a thank you there on a live streaming thing. I don't know, but I will assume that I'm not. Right, so but the index is no longer accurate. So you could do something like this, put it in a dictionary, have your dictionary contain funcs, 5 minutes, okay. Oh, right, but that's fine. This is okay. I would be fine with this, but there's better ways. I'm going to blast through this as fast as I can. By the way, folks, reach out to me on Twitter, reach out to me wherever. I am here to answer questions. There are kids in my house. I hope they won't invade this room. We could create a generic parser using this. Fine. What the smarter way to do this is to use attributes. Create attributes which you can attach to the data and then use the attributes to signal what needs to be done. This is a massively more maintainable thing to do rather than holding all of those different funcs in different things. Okay, so what it means is we can create a generic episode data, we can inherit off that with the specific of the season, and then attach a tag here which says what's the season number. This is a static value for each season, and we'll say that for the title that we'll attach an attribute which says CSV position is this. There we go. So this now just means now I'm not going to go too much into the code because I don't have time, but there's a whole load of rather nasty code to grab these items out. I can show this another time. It's quite nasty, but being an extension method, I would just do, you don't worry about it. It's extension method, shove it in the back. And then so on. You can just write one great big generic parser which uses get attribute extension methods to select out the data you want. And we never need to write one of these again. And that means that all of our episode data classes looks rather like this. That's it. This is incredibly easy to read and maintain, and if it turns out later that the CSV position's moved, you just literally change this, and you never need to change anything else. And if the season number changes, whatever, every time we need to throw in a new season, we just create one of these classes, attach the attributes, done. That's it, easy. And yeah, you can also put in line delimiters and field delimiters if it turns out that the data of one of the other seasons uses something radically different. Still covered. It's all still good. Right, that's it. Wow, I made it. I had to skip at the end a little bit there, but that's fine. Again, I can't see the chat. I don't know where I would go to see that, but oh, hang on. Ah, I've just found out where the chat is because I've been moving so fast. I think no, that's not it. No, okay. Oh, that's our private chat. Okay, haha. There's Mario. Are there any further questions for anyone? Can't see any other questions. Okay, fair enough. As I say, this is my website. Feel free to come find me. I'm on Twitter at @MadSimonJ. Please feel free to reach out to me. I am happy to answer any questions. And I can talk functional programming and all sorts of other topics as well if anyone's interested. So thank you very much, everybody.